Hello everybody. In this video I'm going to show you how to do the graphing of functions. If you have a function, this also represents a graph. So you should be able to build a graph out of an equation or function, right? And I'm also going to show you how two functions are related to each other's in a graph. Or if you graph them in the same coordinate system, how are those two graphs going to be related to each other's? Now I'm going to do this once. I'm going to graph it once, and I'm going to give you a shortcut towards the end so that you guys don't have to graph anything, right? Just by looking at the equations, you are going to know how these graphs are related. Okay, so the first thing that we have to do is we have to find the values that we're going to plot into, or that we're going to convert into a graph. So I labeled those into the blue and the red graphs or functions, right? So let's find the values for the f of x function. How is this going to look like? Okay, so the first thing that you have to find is what's going to be your domain. What are going to be your x values? So what are the x values for f? And to make a graph, you just need 2 points or 2 values of x. Just to make sure that we are on the right track, I'm just going to choose 3 values. Okay, and you can choose any 3 values that you want. It can be all positives or all negatives, or some negatives and some positives. It really doesn't matter. So just to keep it simple, I'm going to select 0, 1, and 2, which are the smallest values that, smallest positive values that I can choose. So those are going to be my domains. I also have to find the corresponding ranges. And in order to find the corresponding range, I have to find f of 0. So I have to substitute 0 into the function. I have to find f of 1, and I have to find f of 2, which means I have to take these numbers and substitute in the blue equation. So we're going to try to find this value right now. Okay, let me just fix this really quick. And to find f of 0, that's the first one, I'm going to replace the x in my original equation for a 0, right? 2 times 0. And the second one, I'm going to replace the x for the number 1. And on the last one, I'm going to replace the x for number 2, right? We're talking about this equation over here on the top that represents f of x. And this is going to tell me the range. So what is the corresponding range? For the first one, 2 times 0, that's 0. So my first corresponding range, I'm just going to color code it, going to be 0. My second corresponding range is going to be 2 times 1, that's 2. And my third corresponding range is 2 times 2, that's 4. Okay, so that's the first thing that you have to do. You have to find the values for the domain and the values for the range. And it looks like I already have my values in here. Okay, the values for the domain and the range. I'm going to convert those into coordinates really quick. I'm just going to convert them into a set of numbers. The first coordinate, that's 0, 0. The second coordinate, that's 1, 2. And the third coordinate, that's 2, 4. Those are the values that I just found over here, right? So now that I have these coordinates that represent the function, the blue function, to f of x equals to x, I'm going to plot those into the Cartesian coordinate, okay? So let me bring these values over here. I already have a Cartesian coordinate system somewhere over here. Okay, and I'm gonna plot these values in there. So just we remember this is the f of x function, right? F of x equals 2x. Those are the values that I got. So the first thing that I'm going to do is I'm going to plot 0, 0. So how to read a Cartesian coordinate? The horizontal axis, this horizontal axis over here, is going to carry the x values. And the vertical axis is going to carry the y values. Okay, so right and up, those are positive x's, positive y's. Left and down, those are going to be the negative values, right? Negative x's, negative y's. So let's plot the first coordinate that I have in here. That's 0, 0. That means I'm not going to walk anywhere. I'm not going to rise anywhere, right? 0, 0, that belongs in the very, very, very center. So I'm just going to put a label in here. 0, 0, that's the first value. Okay. The second value of my coordinate, that's 1, 2. The first one's the domain, the second one's the range. So the domain says I have to walk 1 unit, that's a 1, and then I have to go up 2 units. 1, 2. So this is going to be my second point. That's 1, 2. I walk 1, and then I rise 2. Okay, let me put a small label in there for my second point, 1, 2. And for the third point, the same thing, right? My third point, that's 2, 4. So the first one's the domain, means I have to walk 2 in the positives, right? So from the center, 1, 2, and then I have to walk 4 up, which is 1, 2, 3, 4. So this is my next point in the graph. So all of these points are going to represent a line that comes with that equation, right? This point is 2, 4. So can you see that I'm going to have a trending here? So what I'm going to do is I'm just going to draw a straight line in between those points. Okay, just a straight line, the best that you can. And this is a line, you know, if you give it the values for the domain of 3, 4, 5, 6, and 7, then this line is just going to keep increasing. So I'm going to put some arrows in here to denote that this is just going to continue all the way to infinity. Okay, so the name that this graph is going to take is going to be f of x equals 2x. So the equation f of x equals 2x represents this line over here. Okay, that's the first thing. Now we're going to do the same thing for the other equation, right? Going back to my original equation, now I have to find the values for the g of x function. So we're going to do the same thing, right? I'm going to find the values for x, and I'm going to find the corresponding values for the function. Okay, I'm going to take the same domain, right? 0, 1, and 2, and let's see what the correspondence is. Since this is the g of x graph, now I'm going to find g of 0. So substitute the 0 into the g function, g of 1, and g of 2, and those are going to give me my values for the ranges. Okay, so my equation over here is 2x plus 2. So it's going to be 2 times 0 plus 2, 2 times 1 plus 2, and 2 times 2 plus 2. Let's see what the values for the range are. So first one's 2 times 0, that's 0 plus 2. That's going to be my first range, 2. The second range, that's going to be 2 times 1 is 2 plus 2. That's going to be 4. That's my second range. And then the third range, 2 times 2, that's 4, plus 2, that's 6. And that's my third range. So I already got these numbers over here. If I want to write those as a set of coordinates, again, the first point is going to be 0, 2. The second point is going to be 1, 4. And the third point is going to be 2, 6. These points over here. Okay, so I'm going to take this down to my Cartesian coordinates, and I'm going to plot those in there. Okay, so let's see. Just put it over here. So that's the g of x function, and the g of x function, just so we can remember the equation is going to be 2x plus 2. Let's see how these two graphs are going to be related to each other. Okay, so let's plot the first number. That's a 0, 2, which means 0 for the domain means I'm not going to walk horizontally. I'm not going to walk horizontally, but I have to go up 2 units. 1, 2. This is going to be my first point of my g of x function. Okay. Oops. Oops. Okay, let me get rid of the red point. So that's my first point, and this, if I were to give it a label, that's going to be 0, 2. That's a point 0, 2, the first point of my g of x function. The second point of the g of x function, that's 1, 4, which means I have to walk 1 on the x-axis, and then I have to rise 1, 2, 3, 4. That's where my next point is going to be located. Okay, and the name of this point is going to be, if I were to give it a label, it's 1, 4. That's the second point, the f of x function. Okay, and I don't know why I'm doing this. I might as well just put the labels over here, right? 1, 4. Maybe shouldn't be complicating things. Okay, and the third point is going to be 2, 6, which means I'm going to walk 2, 1, 2, and I'm going to rise 6 units, 1, 2, 3, 4, 5, 6. So this is where my next point is going to be. Okay. my point, I'm going to give it a label really quick. That is 2,6. So now that I have 3 points, all I need, remember, all I need is just 2 points to make a line, right? So I'm just going to try to line them up nicely. And let's see if I can connect those dots. Of course, this is a infinite line, right? These two lines are going to be going all over and over, all the way to infinity. And if I were to put a label to this graph, that's going to be the g of x equals 2x plus 2 graph. Now, I'm going to get rid of some labels in here just to answer the question more clearly. Okay, I'm going to get rid of all of the coordinates really quick. So I'm left with the two lines. Okay, the g of x and the f of x. And the question says, how is the graph of g related to the graph of f? Right? How are those two lines related? Now, look at the equations. Right? Look at the equations that we have. We have equation 2x and the equation in the top. That's also a 2x equation, right? But we have an extra 2 in there. So the f of x equations in this case, they don't have a constant, right? You can think about it as 2x plus 0. There's no constants. That's why they go through the center. So any equation that doesn't have a constant, it's always going to go through the center. So whichever line, right, whichever way this line looks like, it can be a parabola or it can be a circle, right? But if it goes through the center, let's say I'm just going to make a sketch of another graph. I'm just going to make a crazy sketch of another graph, right? If that were to be my line, all I know from this line is that it does not have a constant, right? Whatever the question is, it doesn't have this constant over here, okay, because it goes through the center. So I know 2x is going to go through the center for sure. If you try to find the graph of, I'm just going to come up with another function, right? 3x, then this line is also going to go through the center, right? It doesn't have a constant. But when the graph has a constant, this is going to tell me how many units is shifted either up or down. And you can visually see in the Cartesian coordinate that this line, the blue line, it looks like it shifted up 2 units, right? So I'm just gonna make another sketch of the line, right? Copy it really quick. So this is my blue line. That's my blue line. And let's see if I can make it. I don't think I'm gonna be able to make it migrate. But let's see if I can copy it really quick. So I'm just gonna copy my line. And let's see if I can paste it here. Kind of. So this is my line, right? The line of the equation. Just a point. And it virtually looks like this line, which was originally in there, it migrated up 2 units, right? It merged, or it went from the center back up 2 units, right? That's 1 unit, that's 2 units. So that's what happened to the line, okay? And this we can see in the equation. The equation is going to tell me where that line is going to migrate. That's a +2, that means the line is going to shift up 2 units. Now, without doing all of these calculations of domains and find the ranges, I'm going to give you another equation. Let's say this is h of x equals 2x minus 3. This is what the equation looks like. Now, you don't have to do all the calculations. You should know where this line is going to be, okay? Because this is also a 2x graph, just like the other graphs. So it's going to be the same straight line with the same slope. Okay, and this number, the constant, is going to tell me how many units this is going to shift up or down. So let's take my sketch of the line, and according to this equation that says 2x minus 3, it means that this line is going to shift down 3 units, right? So from the center, it's going to go down 1, 2, 3 units, and this is where my line is going to be. If I do the PEMDAS, not the PEMDAS, excuse me, if I assign some values for the domains and find the ranges and plot those numbers, this is what the line is going to look like, right? How do I know that? Because it says this is a 2x minus 3, so it means it's going to go down 3 units from the center. Okay, 3 units from the center. Just to make it a little bit more easy to picture, I'm going to raise the x-axis just to make it easier to picture, right? Sometimes people confuse the vertical movement with the horizontal movement. But if you look at it this way, you're going to see that the graphs are going down, right? The lines are going down in vertically according to whatever constant you have. So the one that doesn't have a constant, in this case the f of x, that's the one that goes through the center. It used to be my center for the Cartesian coordinate. Okay, and then I can come up with some other crazy equations, right? 2x minus 5. I'm just gonna give it another letter for the function. So that means 5 units from the center down, right? That's 1, 2, 3, 4, 5. And this is where my line is going to be, right? The line for y of x, 5 units down. Of course, all this is not really accurate because it has to be parallel to all of the other lines, right? Of course, this goes all the way to the infinity. So this is all you're trying to look for, right? So look at the equations. Just take a look at the equations. F of x to x, g of x to x plus 2. I know the graph shifts up 2 units. Okay. So if I give you another quick example, right? The f of x equals x squared and g of x equals x squared plus 5. Right? How is the graph of g related to the graph of f? Well, I know the graph of f goes through the center. It has to go through the center because it doesn't have a constant. And I know the graph of g has to go 5 units up. And this is where the graph of g is going to look like. And the graph of f of x, it looks more or less something like this, a parabola. Okay, so the graph of g on this case is going to look like a parabola also, but going up 5 units. Now, if I give you another example, see, I didn't even have to graph anything. Okay, there's a website that's called Desmos. So you can go there and access the graphing calculator. If you want to plug in these equations, it's going to show you a graph of these equations. Okay, so again, f of x, let's say this is x cubed, and g of x is x cubed minus 2. How is the graph of g of x related to the graph of f? Well, I know the graph of f, whatever that looks like, whatever it looks like, it goes through the center because it does not have a constant in here. It does not have an extra number. Okay, and whatever the graph of f looks like, the graph of g is going to be the same shape, but this is going to shift down. The negative means down 2 units. So I know the graph of f is going to go through that point. And the graph of f of x equals x cubed, I believe it looks something like this. You can go to Desmos to see if it looks like that, right? And then the g of x graph, if it's going down 2 units, it has to look the exact same, but shifted down 2 units, vertically down 2 units. If you want me to work out some more examples, just send me a quick email. Let me know, and I will gladly work out more of these problems.